Alright, so in this video I wanted to talk about how you can augment LLM with graph data, and this is part of the LangChain crash course series of this YouTube channel playlist, right? And also, if you are following my YouTube channel, like recently I have published a few of the videos which are related to graph neural network. So in case you haven't watched that, you can go ahead and watch that to understand how the graph neural network works, and that will kind of give you a basic understanding of how the graph is and how we can represent graph in terms of the machines, right? Okay, so let's get started. So first of all, like few of the installations which are related to this, so that I am doing, then I am loading this ISLR book, which is like one of the famous machine learning book, which is like Introduction to Statistical Learning with Applications in R. So that book I am loading, and I am database using this book. So, and we will try to build a GraphQAChain. So generally we use the RAG as one of the approach to build any QA chain, right? So the problem associated with RAG, that once you create the chunks, there may not be relations maintained between the chunks, right? So one way to tackle that issue is you can create overlapping size between the chunks to establish relationship between multiple chunks, but generally those are like independent chunks which does not have the interlink between that, right? So using graph you can create triples of data where you can have multiple chunks of the data, and which can be interrelated with nodes and edges in terms of graph, right? So once I load this book, so I will do a split on this, and I will get like 444 instance of this book. So you can see, like using this PDF loader, I am like loading and splitting that. So we will have like 444 instance of split. So first of all, like I am just looking into the data set, like first 5 page contents or the chunks which what we have here. So after that, what the first page content, right? So here we can see like we have this page content like which talks about the initial page of the book, right? So then we have then I have initialized palm 2. So I was trying with different open source model. Llama 2, the 7 million model version, is kind of not working well for this application where I am trying to build a GraphQAChain. And so I tried with Palm 2, and I have seen that Palm 2 is kind of working well for this. So it can like create the triples much more better way. What this triple is, we will slowly discuss in this video. So after that, what I am doing is I am importing from LangChain.indexes the graph index creator. So there I am passing the LLM as the model in this graph index creator, and after that I am checking a random page content which is the index which is present at 70th index, and I'm trying to create a graph out of that page content, right? Now this is how the relationship between the graph is stored for this book, right? So it will actually internally it will try to create triples. So this triple is nothing but there are certain nodes, and also there is a relationship between those nodes, right? So if related to linear regression, right, the second and third example, so it has created nodes and also the relationship between them. So how you can read this is linear regression used for predicting quantitative values, right? So it will create two nodes which is like linear regression and predicting quantitative values, and the relationship between them is used for, right? Then we have like linear regression problems in astronomy and first successfully applied to. So how you can read this is linear regression first successfully applied to problems in astronomy. So similarly we have this triplets gets created for each of these nodes, and after that you can do a visualization of this graph, right? So as I was mentioning, like linear regression is kind of a parent node, and we have like two child nodes which are like predicting quantitative values problems in astronomy, and those are like the relationship between linear regression along with these two nodes, right? So similarly we can like go and check the other type of nodes which are, or the triples which are present here, right? So it is like in 1980s like these things are kind of originated. So in that way, like you can visualize and try to understand this plot of this graph, right? Okay, so after that what I am doing is I am creating graph for set of page contents, right? So I have picked up like page contents which are like running from 10 to 30, and using those page contents I am creating graphs, right, using this index creator. And after that what I will do is I will use this networkx compose function to create a graph. So this networkx compose GLH works in this way, like compose graph G with H by combining nodes and edges into a single graph. So it will use G as a base graph, and then it will add the H, and it will add by combining the node and edges, and it will create a single graph, right? And it will return a new graph which will be of the type of G, right? So that's why like we created around 20 graphs right here in this phase. So after that what I am doing is I am taking a base graph which is G, so that is the first graph here. So that is the first graph which I'm using here, that I am calling as graph nx, and then I am kind of looping the other graphs and adding those graphs to this parent graph which is the 0th graph, right? So that's like I'm running a for loop and then adding all other graphs that are present here, right? So after that I'm creating a like network entity graph from LangChain, and then we can visualize this, right? So this is like all about the content from page 10 to page 30, how it looks like, right? So we can see like ISLR is kind of a parent node, and these are like the child nodes which has certain details, author names, and all those details are kind of present here, right? And like chapter wise details are also present. And this first thing which you see, right, this Nevada and state US gold, so this is actually example that is being passed to this as an instruction, that using this example it will try to create the other graphs that are present inside the data. So this is actually not part of the data set. So this generally when we use like OpenAI models, we will not see this example is coming as output in the output graph, but in case we are using the other open source models, so LangChain doesn't work very much well with the other open source model. That's why this example is coming as in the graph. So this is how the graph looks like, and you can visualize. So I will give the description in this video description the link of this notebook, and you can like try and play around adding more page contents, and they'll try to see how it works, right? So you can see like what are the chapter 1 holds in the data set, then what are like how the statistical learning is related to different nodes, and also this type of details are there, right? So after that what we will do is we will create a GraphQAChain. So here we will create a kind of knowledge database, and we will try to pass a prompt as a question and try to get the answer, right? So using this GraphQAChain, I am passing the LLM and the graph, and also I'm mentioning verbose equals to true, so that will kind of tell me how this operations are going on. So the first question which I'm passing here is which chapter has the details about linear regression, right? So it tells you like the chapter 2 has the detail. Now what is written in the chapter 2 about linear regression, right? So with very specific detail it is mentioning that the linear regression is a statistical method, so that is being written in the chapter 2. So I think it's picking up one of the node which has a linear regression, and the child node is kind of a statistical method, and with that relationship it is trying to give you the answer. Then I am asking what is MAC and what chapter has details about MAC. Now it gives you the full name of MAC, which is mean squared error, and it also tells you which chapter, like chapter tail has the detail of MAC, right? That we can learn from ISLR, right? So from this book, so you can see that all these triplets it's looking into it, and like it's trying to figure out what are the different type of things we can learn using this ISLR. So you can see like ISLR has a relationship with recommender systems, natural language processing, dimensional reductibility. So all these details are coming up here, and once it finishes the chain, then it gives you the output, which has a detailed thing which you can learn using this ISLR book. right? So let me ask a specific question using this, which is related to random forest. Let me see if my dataset contains any details about random forest. So I will ask what is random forest, right? And let's see if that dataset contains that detail or not, right? So yeah, it's kind of giving you an answer that it is an ensemble learning. So indeed a random forest is kind of ensemble learning. So these details are much more concise because of the nature of how the graph is created. Yeah, so that's all I wanted to discuss in this video. So I hope you got an understanding how you can like augment a LLM with a graph data set, and this is very a use case specific thing which you need to think about, like for which use case you want to fit the data as kind of a graph format and then try to extract informations out of it, right? So I hope you like this video, you found it useful. This is kind of a new thing which is like how you can like augment LLMs with graph data. So with this I will end this video. So if you haven't subscribed this channel, please subscribe and share this content with your friends and colleagues. Thank you. See you in the next video.